Good morning everyone. My name is Elisha son of Kesavan and my matrix number is 33DCE21F1077. In this video, we will talk about Izod impact test for material science and engineering.
Hello everyone, my name is Izod Narisha binti Ismail. My number matrix is 33DCE21F1085.
Hello guys, my name is Aminul Alif bin Amin. My matrix number is 33DCE21F1080.
Okay, today I will show the lab about Izod impact test for cast iron. Okay, for objective is to find the impact resistance of melt steel and cast iron. For apparatus use, we will use impact testing machine. Okay, for next step 1, select the Izod test specimen. There have two, cast iron and melt steel. Okay, we can select the specimen. We will select cast iron, and here we have leg to 17.6.4, breadth B is 9.4, deep D is 9.16, and last deep of notch D is 2. Okay, for next step is step 2. Test for friction loss is conducted by adjusting the pointer to 664 joules. Then the pendulum is released by operating the lever without keeping the specimen. Loss of energy due to friction EF is 2 joule. Okay, for next step is step 3. The Izod test specimen as per Indian standards is 3766/1677 is placed in position. We have radius of curvature of striking edge, test pitch, striking head, angle of tip of striker, direction of impact, angle between underside of striker and face of test piece, and for last is support. Okay, next for step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is not down. Okay, we can tap there. Total loss of energy during the transit of hammer ET is 5 joule. Energy for failure of specimen ET minus EF is 3 joule. Okay, next observation for trial 1 is initial energy of hammer is we get 164 joule. Average loss of energy due to friction EF is 2 joule. Total loss of energy ET during transit of hammer is 5 joule. And for the last is energy for failure of specimen is 3 joule. Okay, for step 3 is the Izod test specimen as per Indian standard is 3766/1977 is placed in position. This is for trial 2. Selected specimen is cast iron. Okay, we get leg L is 76, breadth B is 9.44, deep D is 9.46, and for the last is deep of notch D is 4.46. Step 4 is the pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is not down. We get total loss of energy during transit of hammer is 7 joule. Energy for failure of specimen is 5 joule. Observation trial 2 is initial energy of the hammer is 164 joule. Average loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer is 7 joule. And for the last is energy for failure of specimen is 5 joule. Okay, for step 3 is trial 3. The Izod test specimen as per Indian standard is 3766/1977 is placed in position. Selected specimen is cast iron, and we get lead L76.4, breadth B is 9.4, depth D is 9.16, and for the last is depth of notch D is 2. Next is step 4. For trial 3 is the pendulum is released. The hammer strikes against the specimen, break it and swings, feature the observation is knocked down. And then we will get total loss of energy during transit of hammer is 7 joule, and for energy for failure of specimen is 5 joule. The last is we will get observation is loss of energy due to friction in joule. Trial 1 we get 2, trial 2 we get 2, and trial 3 we get 2. For total loss of energy during transit of hammer is trial 1 is 5, trial 2 is 7, trial 3 is 7. Okay, for the last is energy for failure of specimen. We will get for trial 1 is 3, trial 2 is 5, and for trial 3 is 5. Average energy for failure of specimen is 4.33 joule.
48 energy for failure of specimen ET minus EF equals to 46. The observation initial energy of the hammer equals to 164 joule. Average loss of energy due to friction equals to 2 joule. Total loss of energy ET during transit of hammer equals 48 joule. Energy for failure of specimen equals to KU over impact value equals ET minus EF equals to 46. For trial 2, the Izod test specimen as per Indian standard IS 3766 1977 is placed in position. Selected specimen mild steel, length 75.9, breadth 95.9.5, depth 9.7, depth of notch 5. Step 4, the pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is noted down. The test place was not broken by striking energy of the testing machine, so the impact value obtained is indefinite. Observation for trial 2 is initial energy of the hammer 164 joule, average loss of energy due to friction 2 joule, total loss of energy ET during transit of hammer is indefinite. Energy for failure of specimen equals to KU over impact value equals indefinite. Next, for trial 3, selected specimen mild steel, length 76.4, breadth 9.3, depth 9.16, depth of notch 2. Next, the pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is noted down. Total loss of energy during transit of hammer 48. Energy for failure of specimen equals to ET minus EF equals to 46. Observation in trial 3, initial energy of the hammer 164 joule, average loss of energy due to friction EF 2 joule, total loss of energy ET during transit of hammer 48 joule. Energy for failure of specimen equals to KU over impact value equals to ET minus EF equals to 46 joule. Observation for overall is loss of energy due to friction. For trial 1 is 2, trial 2 is 2, trial 3 is 2. Total loss of energy ET during transit of hammer for trial 1 48, for trial 2 0, and for trial 3 is 48. Energy for failure of specimen equals to KU over impact value equals to ET minus EF. For trial 1 is 46, for trial 2 0, and for trial 3 is 46. Average energy for failure of specimen equals to 46.00 joule.
In conclusion, impact test is test used in studying the toughness of material. Toughness is connected with both ductility and the strength of the material, and Impact test involves the sudden and dynamic application of the load.